Hello, I'm Wallis McGuire, and today I will be presenting my final project, which is facial detection using cubic splines. This is for my CSCI 3656 numerical computation class at CU Boulder. So why facial detection? Well, I was on my sister's phone and it accidentally locked on me. And if I angled it just right, I was able to get back into her phone. So I was able to unlock it. And it got me thinking, how does facial detection and Face ID on your phones even work? Well, using the methods that we've learned throughout the semester, I was wondering if one of these methods was used for facial detection. And in my research, I found that cubic splines was something that was used for such things. So what are cubic splines? Well, cubic spline interpolation is a way of finding a curve that connects data points with a degree of 3 or less. Their main points is that they use polynomials to estimate the curve. And what's good about using polynomials is that they're smooth and continuous. Um, I thought this was perfect because what I wanted to do was take pictures of people's mouths and try and map out the bottom lip to see whether or not they were frowning or smiling. So if I map out the bottom lip or fit a curve to the bottom lip using cubic splines, I would be able to determine using software whether or not that person is smiling or frowning. Because as if a person is smiling, they look like this, and our bottom lips have a concavity that is upwards. And what that means mathematically is that the curve of our lip, or the curve of our lip's second derivative, is positive. And if we are frowning, the curve of our bottom lip is downwards, which means the second derivative is negative. So I thought if I could fit cubic splines to images of people's mouths, specifically the bottom lip, I could take that curve's second derivative and figure out whether or not they were smiling or frowning. And this would allow me to determine how accurate facial detection can be when using cubic splines. So on the graph to the right, you can see that cubic splines take a bunch of derivatives, so the first, the second, and the third, and they connect them all together. And so the derivatives are what you see in brown, purple, and red. And these all connect together to map out the curve of those points, as you see in the green curve. And I was hoping we could do this for mouths. So as for the data I'm using two data sets. One I found from Kaggle, which is just a machine learning AI um, website where you can find data sets. And they have a variety of things. So I was able to find a fairly large data set, over 300 images of people's mouths. I wasn't able to determine where these were taken or who they were taken by, but I figured the authenticity of the data set was still reliable because it is just pictures of mouths. So it's not like anything can be fabricated, or at least even if it were, it would not affect um, my operation. And then the second data set I found was a little bit more reliable because I was able to figure out and determine where they were taken and who they were taken by. So the second data set is from Olivetti. It's an Olivetti Faces data set, which contains a set of face images taken between April 1992 and April 1994 at the AT&T lab in Cambridge that were then converted into grayscale by Olivetti. So the database was used in the context of a face recognition project similar to mine, where carried out in collaboration with the Speech, Vision, and Robotics group of the Cambridge University Engineering Department. So I figured this one would be quite reliable and very authentic as to what I'm using it for in this project. As you can see, though, there is, at least in the first picture, there is a bit of nose and some other features in the images, and that's true for a lot of the images in both of these data sets. So what I had to do was crop all of the images in these data sets to just the mouth. And this sort of streamlined the process of mapping out the cubic splines because if I took the most bottom part of the image, it might be mapping out the chin, which is always concave up. So that doesn't really help me. So I had to crop them down to be just the mouths. And as to how I was able to actually get a computer to even read an image, I used the package OpenCV, which is fairly straightforward and many people use. It's a very common package when processing images. But basically what it does is it takes the image as seen in the first image and it converts it into grayscale, which is basically just turning it into black and white. It then analyzes the intensity and brightness of the image. So places where it's the darkest is going to be where we have a contour. And a contour is basically just the outline. So what you see in white and also green there is what's going to be considered a contour, and that's going to outline our lips. And as you can see, when it comes to the top part, it's a little bit more um, all over the place. So taking the bottom lip using this package makes it even more accurate. So that was a good option. So then in the fourth image, we actually have to take points that we can fit the cubic splines to. And all of those red points, this image is rather small, so I had to blow it up, but there's about 10 or 11 points there that will be able to fit the cubic spline. As you can see, it takes relatively like good at mapping out that bottom lip. So we're going to take these points and we're going to put it onto a plot so we can fit our cubic splines to it. And as you can see, I took about 10 or 11 points, which makes the cubic spline itself quite accurate according to the graph on the right. And what you see in that blue line is our cubic spline. So from here, what I wanted to do was take this curve's second derivative to figure out and output whether or not that person was smiling or frowning. And that's what happens here. So when the software takes a second derivative, it takes a bunch of points and it finds where the sharpest upwards curvature is and where the sharpest downwards curvature is. And that's what I mean by max and min curvature. So max curvature is just where it's the most upward and min curvature is where it's the most downward. So there's two ways to detect whether or not someone is smiling. The first is taking the absolute value of these two numbers, because as you can see, the min curvature is negative. So in order to compare them, we'd have to turn them positive. And if the max curvature, meaning more upward, is greater than the min curvature, meaning more downward, then that would mean a more upward curve and therefore a smile. The other way to do this, and the one I went with for the final product, is to take the average of these two numbers, and if the average is positive or greater than 0, then it would be an upward curvature and therefore a smile. And if the min curvature is greater, or if the average curvature is less than 0, meaning negative, then the curvature would be downward and therefore a frown. I decided to go with the second option purely based off of it would be more smooth and it makes more sense mathematically, but algorithmically, they are the same and would produce the same results. As for my results, I needed to run my program on all of the images that I had because I wanted to see how accurate cubic splines could determine whether or not someone was smiling or frowning. And as you can see, like I couldn't just go through and count 300 derivatives. So I came up with a process to loop through all of the images. And my first couple of tries, as you can see to the very left, the frowns were greater than the smiles, which was false. The data that I was given in both of them, there was more smiles than frowns by a very high margin. So almost all of them should be smiles. And even in the second data set, only about three or four were frowns. So as you can see, that led to an accuracy for the first data set to be about 62%, and then the second to be about 74%. So that means 62% of the 62% of the time when a smile was actually a smile, it was able to detect it correctly. But other than that, it detected it as a frown. Um, and these first couple of tries was because I wasn't using enough points. When my first tried doing it, I was only using 3 to 4 points, which is basically the minimum you need in order to do a cubic spline. But when you give it more points, it's able to accurately determine what the curve is going to look like. So obviously these last ones that I determined, I was using almost about 90% of the bottom lip points. That is not to be confused with all of the points, just just the points from the bottom lip. I used most of those in order to graph the curve, and that gave me a much better accuracy and correctness than originally. Because as you can see, I went from 3 to 4 points to about 10 or 11 each time. So these accuracies are very good considering if it was closer to 50%, that would be like saying the algorithm just flip a coin and see which comes out. But the fact that they are well above, especially for that second one, well above 50%, that means that the algorithm is actually running quite well. So in order to refine this, I would say the cubic splines are actually quite accurate. It is not the cubic splines themselves that aren't that like get that accuracy a little low. Even though the accuracies themselves are pretty decent, it's the image processing that kind of made a detriment in this project. And the data sets themselves. So according to the image processing, like I said before, I had to crop them, but I also had to remove some of the images from the data set because um, the package OpenCV just couldn't read them because they were low quality or too bright or etc. reasons. But even from the ones that I did remove, some that remained you still couldn't determine because, for example, in one of the images, someone was wearing a mask. And so you couldn't even detect any lips, which was weird for it to be in a data set of mouths. But that was another reason that maybe the accuracy was a little lower than it could have been. But it is impossible to go through 300 images. So I wasn't able to refine it any more than I already did. But that is something that I could try and implement in the future, especially with the image processing, using eigenvectors and eigenfaces to make the processing a little bit better and map out the face a little bit better would definitely make the accuracy of the cubic splines even increase like tenfold. So I think with the limitations of the data sets and also the limitations of the processing power that I had, the accuracy was lower than it could have been, but that was not to fault the cubic splines, which themselves I feel were very accurate in that they consistently mapped out the bottom lip, um, the ones that you could at least process and did them correctly. So I think cubic splines is a good implementation to use and something I could definitely explore in the future with more advanced algorithms and subjects. Thank you. And here are my references.